Hello and welcome to week 15 in artificial intelligence. This week we've got quite a few topics to go over: robotics, philosophy, and ethics of AI. Maybe talk a little bit about the future of AI, though I'm probably going to skip over most of that. So jumping into our agenda again, we'll talk a little bit about assignments. We typically do that. Then we'll talk about chapters 26 and 27, and I'll probably leave the future of AI to you. Because the reality is that's kind of what it's going to be, and anything that I predict is just going to be a guess. So moving on. Assignments. We're into week 15. This week you've got a paper that is due around robotics simulation. The idea here is we'll talk about it here, right here. You're to do some research on robotic simulators, environments which allow you to simulate what you would do with a robot in a real world. Describe the purpose and motivation of using a robotic simulator. Research a system that enables that. Describe that system in detail, citing at least 4 scholarly sources along the way, and utilizing APA 7th edition. Expect it to be between 1,000 and 2,000 words. Entirely up to you. Cover the topic is the main ask. So the basic idea here is that robots are relatively expensive. So if you were going to want to learn how to control a robot, probably want to do so in a simulated environment first. So find an environment that does that and talk about it. The rubric, which will be used has been used on all your other papers. Do shoot for the excellent column. That hinges upon having a good introduction and conclusion. Introduction and conclusion should both contain your thesis statement. So what is the point of this paper? And it's basically going to be to discuss, robotic systems. And then what are the subpoints that you're going to cover as well? The point of that is to kind of establish the context of the material you're discussing, ideally establishing relevance and importance, and telling the reader what is the purpose of your paper. So why should you read it? And you should be able to do all of that basically in a paragraph. Once you move past the paragraph, you probably then shift into your subtopics, which you probably want to have organized with headings. Makes it a whole lot easier for your reader to follow what you're talking about, and it also makes the paper look pretty good as well. Those are the key elements that you want to shoot for on your papers. Your discussion for this week is to talk about robotics. Pick a topic that was interesting to you, maybe an example of a real world robot that you've seen in action, and maybe you've got a Roomba. Could be that simple. And then post, and then make sure that you do respond to your classmates. The same useful resources that we've talked about throughout the course, including the example programs, which probably less relevant at this point in the journey than they were earlier. Moving into chapter 26, which centers on robotics. So what are robots? So the key concepts here, it's a physical agent that exists in the real world. That's a key concept. Is it's similar to the autonomous agents and intelligent agents we might have talked about in the past, but in this case, they actually exist in the real world. Some of these terms are pretty clear and common sense, but it doesn't hurt to go over them. Just so that we're very clear and concise about our definitions and discussions of these things. Effectors are things which are used to interact with the real world. They may include their legs, their wheels, their joints, their grippers, flippers, wings, rotors, whatever it might be. It's something that interacts with the physical world. Sensor is a way of getting information. Sim to real, pretty interesting concept, which is you take the things that you learn in a simulated environment and apply it to the real world. Might be relevant too to think about that in the context of writing a paper about a simulation environment for simulating robotic interactions. And in order to be successful using a robot, you have to pretty much do most of the stuff we've talked about in this course. You need to be able to do some sort of probabilistic state representation to kind of represent what you think the state of the world is. You need to be able to perceive, need to be able to plan. Probably going to be doing some unsupervised learning, maybe doing some reinforcement learning, probably some game theory in the mix as well, and more likely not some computer vision, so that you're observing the world and making determinations to do planning and all the other stuff, right? So they all kind of are necessary to do a robot. So what's the hardware look like? There's some key terms here. A manipulator, something that changes things, right? So it's typically an arm. It doesn't have to be necessarily attached to a robot body. You could have a robotic arm that is used in the manufacturing process that is not attached to anything other than the floor or table or maybe the ceiling. You also have mobile robots. These are robots which move around, as the name would imply, and their motivation could be any number of ways. They could fly in the case of a quadcopter sort of drone, or unmanned aerial vehicles. They could be underwater. It could be essentially a submarine of some sort or whatever, where they are autonomous. There's no tether. They're running on their own and making decisions on their own. They also could be rovers, vacuum, self-driving cars. They may have legs, they may have wheels, but they've got some mechanism of moving. And they typically are probably going to have some sort of sensors, likely active and passive, but they definitely are going to have a sensor to be able to read things around their environment, either directly or indirectly. Examples of mobile robots, you got a little rover up there, upper left-hand corner. Then you've got robots that walk. I think that's like a gyroscopic sort of robot, and then dogs that play football, kind of, or soccer. So basically, lots of different types of robots that move. A manipulator or an arm typically has some degrees of rotation and freedom, and they typically move in various dimensions, ideally pretty much all dimensions, so that they can interact with the world in a useful way. You have sensors, and that's going to include anything from sonar, laser rangefinders, radar, LiDAR, GPS. You're going to have imaging sensors such as cameras, infrared, visual. You may have accelerometers detecting motion, inertial sensors as well, force sensors, lots of torque sensors, any number of sensors along the way, kind of trying to read what's going on with the world. Could be wind speed sensors, any number of things. But the idea is to gather information about the domain in which this robot is existing, so that then those things that we talked about at the beginning can be used in combination. So they can construct a probabilistic representation of that world and then plan an appropriate action to reach some goal to accomplish whatever it is they're supposed to be accomplishing. So perception, how do they see the world or read the world? They typically need to know where they're at. That's a key kind of concept, and they often do that by utilizing landmarks. People sometimes do this in the days before GPSs. You would know where a mountain is whenever you're hiking, so that you know what side of the mountain you're on. Maybe you have two mountains that you use so that you can give a better sense of where you're at. But generally speaking, you need some sort of a landmark to know where you're at, and you also then probably want to do it as part of your planning so you know which way you need to go. So considering the current state and location and the potential state, so you've got x sub t minus 1 and x sub t and x sub t plus 1, you've got some various sort of orientation, which is essentially the pose, and then you've got some observations based upon that orientation. So this is kind of a way of kind of representing visually how you determine where you're at over time. And that's a key concept of these things, is they're moving. And also potentially the world around them may be moving as well. If you think about things that are flying or swimming, they very much may be being shifted by currents that you can't be seen. Or a robot that is motivating on the ground could slide, or it could be on ice. So it may think it's moving, but it's not really moving. Or it may be sliding because something hit it, so it's moving without its knowledge. Mapping is the idea of being able to figure out, given a set of observable endpoints, figuring out roughly where you're at and regards to them. So that's where localization is going to come in. Mapping is basically trying to update a map distribution, a likelihood, a probabilistic map of where things are. So you may not have a true real reading of the world, and so there's some doubt potentially as to the accuracy of the thing that you're looking at. This applies to things like 3D mapping. So imagine that you're in a mine of some sort, and you've got essentially an autonomous vehicle that is going through and trying to figure out where things are. And perhaps this mine is not so good for people. Maybe there's something in the air, or maybe there's a chance of cave-ins, and maybe you want to go and look for something that goes beyond the range of a wire being attached to it. Although in the picture you see there's definitely some wire. Chapter 27 discusses pretty interesting and potentially thought-provoking topics of philosophy and the ethics of artificial intelligence. It's important to consider the things that we're doing along the way to make sure that we're not setting ourselves up for some unexpected and unpleasant consequences. For example, there's potentially some consequences to the internal combustion engine and the amount of changes that we're potentially making to our environment through the emissions of carbon dioxide and the amount of carbon that's being introduced into the world. That's a consequence that wasn't necessarily anticipated at the time that the engines were being created, but they most likely are having a impactful role in the world. So we want to make certain that there's not some sort of similar unexpected consequence of artificial intelligence. We'll start off by discussing kind of the limits of artificial intelligence. There's this concept of strong versus weak AI. The idea of weak AI is that something acts as if it's intelligent. It's more of a simulation of intelligence, not true intelligence itself. It's something that can be perceived as being intelligent, may even kind of act like it's intelligent, but at the end of the day, we don't think it's really intelligent. Strong AI is something that actually thinks and potentially can solve human-like problems, may act intelligently, and they become very close to being human, maybe become self-aware. That's kind of the concept of strong intelligent. There's the argument from disability, which basically implies that a computer can't, it's basically a list of things that computers can't do. The only thing we know that they really can't do, though, is be exactly human. So rather than saying, well, here's all the things a computer can't do, and that's what the argument for disability is, or from disability, rather think of it from the perspective of maybe it does it in a different way than we do it. So what exactly does that mean? Just as we don't fly the way birds fly, why should we expect a computer to think the way that we think? As long as they are able to accomplish similar things and behave in an intelligent fashion, who's to say that they're not intelligent? So when we measure artificial intelligence, how do we do that? One of the classic examples is the Turing test, which is basically, can something be perceived as being human to the extent that you don't necessarily know that it's not? It can't say that it's necessarily been truly passed, but there's been a lot of people fooled that makes you wonder. Cyberlover was basically around doing identity theft, and it did so by interacting with people in a way that made them think that it was real, and people were fooled enough that they gave it their information. And there was some sort of kind of it took advantage of saying that it was speaking English wasn't its first language, for example, because it used that as an excuse to explain away some of the perhaps unnaturalness of its communications. But it was able to be successful, which is kind of concerning. And there's a chatbot named Eugene Ghostman that was able to fool 33% of the untrained judges, so judges that don't know how to look for and assess intelligence in the sense of the Turing test. So it does kind of make you think, maybe it's not as far away as possible as we might have thought. So again, kind of important to think of it from a perspective of how good is good enough. So can machines really think? That's kind of a fundamental question, and there's a lot of fiction that's been addressing the topic. And there's kind of two schools of thought. One is that they would never be able to think. The reason being, the argument is brains are required for a mind. Computers don't have a brain, therefore they can't think. So they can't have a mind and they can't think. It's kind of the biological sort of argument. The polite convention says that only something brain-like is required, not necessarily something that is truly a brain. So if something does something that accomplishes similar things to the function as the brain, then perhaps it can think. These are philosophical questions, not something with an empirical answer, but it is something to consider. Is what is necessary for origination of thought and life, and does life have to look like our life, or can it be something different? And does intelligence have to be exactly the same as our intelligence, or can it be something slightly different as well? An example of this kind of conversation is the Chinese room scenario. The basic idea is that in one room you have somebody that's speaking Chinese to somebody else. In another room you have somebody that is responding to them. So similar to the Turing test, but the person that is responding is obviously working very hard, sweat pouring off of them, right? But what they're doing is they're seeing symbols on the screen. They look up things inside of a series of books, and they respond back with an appropriate response. So, so they're basically, the idea here is that they are just reading it, responding to it in a way that makes it seem as though they are. So it's not quite understanding what they're doing, but they're responding in a way based upon a set of tables that they're given to do. And the idea here is to say, even if something seems to be intelligent and it appears to be intelligent, it might not be intelligent. That's the argument. It's kind of a slight variation on kind of the Turing test approach. Moving on to ethics in artificial intelligence. So there's several key kind of terms and concepts. We want to avoid negative side effects, as I mentioned at the beginning, kind of this ethics conversation, which is we don't want something that has a consequence that we don't foresee to become significant, especially if you start thinking about it in the sense of unaligned goals between potentially an intelligence and a biological life that is not biological. Those two things having a conflict and alignment of goals could be problematic for the biologicals. We also want to make sure that the ethical principles related to artificial intelligence are followed. We'll talk about those in a moment. May want to consider about legality of lethal autonomous weapons. These are things that we may want to think about. Is it appropriate and should it be legal for a drone to be able to make a determination to terminate a human life on its own after having been given clearance by a person? This is the state of affairs, and should it be, though? Surveillance, security, and privacy are obviously things that we'll want to think about and talk about. Fairness, and then trust and bias. So the ethical principles that relate to artificial intelligence, we want to ensure safety, we want to ensure fairness, we want to be respectful of privacy. We have an expectation of privacy in this country that could be certainly circumvented by the use of artificial intelligence in a pervasive way. We do want to promote collaboration. We do want to provide transparency, especially into how decision making is done. And we want to limit the harmful uses of artificial intelligence. Also need to establish things like accountability. Who is accountable for the actions of an artificial intelligence? The creator of the algorithms, the person that instructed it, who's at fault if something goes wrong. We want to make sure that we're upholding human rights and values so that human rights aren't being lost along the way through the use of artificial intelligence. Definitely want to make sure that we're reflecting diversity and inclusion. We don't want unintended biases or biases of any source, intended or otherwise, to be introduced into the decision-making processing. We want to avoid concentration of power into a concentration that is being controlled by an artificial intelligence or people controlling artificial intelligence. And we want to make sure that we're conscious and aware of legal and policy implications associated with the use of artificial intelligence and contemplate the implications for employment and job security within the workforce. It's not to say that these things are all going to be easily addressed, but they're things that we want to think about. So lethal autonomous vehicles and weapons go beyond being an aid to a human to the point of acting without the human. So it is a good example being a drone that flies on its own, that is given a target that it's to look for, and then it does so whenever it sees the opportunity. Somebody's not flying it, somebody's not pushing the button that launches the missile. It is making that determination on its own. And it's the United Nations definition is a weapon that locates, selects, and engages, that means kills, human targets without human supervision. They exist. They're real. They're being used. The question is, should they? And we have long flying missiles as well, which are missiles that can stay in the air for relatively long periods of time by flying at relatively low speeds, potentially with some sort of wings extended or whatever it might be. And then whenever they determine it's appropriate time to engage, they do so. So these are interesting concepts. It definitely demonstrates that the three laws have clearly already been broken. So moving on. Surveillance, security, and privacy have all kinds of cameras in the world today, and cameras can be combined with algorithms that can make determinations about people that are in there, the identity of the people being observed, their actions, how they're moving, and so on. Even things which have been sanitized can sometimes be reconstructed. The example being the Netflix prize, where sanitized and anonymized data was given as part of a contest to determine a new algorithm for video recommendation. And through the use of some clever combinations of data, people were able to identify several people and essentially de-anonymize them. So really kind of concerning. And it hints at sometimes sanitizing isn't enough. AI can also be very much a big brother. You could have a government agency that is truly watching every move you make. It is conceivably doable at this point. The technology exists. It's other things that are keeping it from happening. Fairness and bias is an important characteristic of ethics in general. An algorithm can accidentally be biased by their authors, not intentionally. This can be through their personal experiences, the data they give it, any number of things. You can have societal, gender, age, and other types of biases which can be included accidentally. It could be as simple as the training data doesn't have an appropriate representation of a certain subgroup. So that individuals that are, maybe you're doing voice recognition, and individuals with exceptionally low or exceptionally high voices aren't included, as an example, or maybe they speak with a certain accent. Then there's this concept of fairness. We think things should be fair, but what does fairness mean? Individual fairness is whenever that basically all individuals should be treated the same. Group fairness is a collection of people should be treated the same. So a group of people that can be categorized based upon some sort of a characteristic. A way of achieving fairness may be through unawareness, which is simply don't consider certain attributes, like don't capture them, don't use them. Race is a good example. If you don't have race in your model, you can't possibly be making decisions based upon race and therefore introducing bias. You should have equal outcome, which basically means that different people or groups from different groups should have the same result. So individuals in one group should have the same result as individuals in another group as a representation, assuming everything else is equal. And there should also be equal opportunity. So you should get the same chances, the same choices, the same possibilities, independent of which group you're in. And there should be equal impact. Basically means that the cost of a false prediction should be equally shared amongst people of different groups. It's important that we trust AI, and that means that in order to trust something, you need to have verification validation. Certification may also be a way of increasing the level of trust. Should also be transparent so that people know how decisions are being made. That means it also kind of needs to be explainable, and that is kind of challenging in some fields of artificial intelligence. But there needs to be some mechanism being able to explain why a decision was reached. And so those are the kind of the pieces of trust and transparency to consider. And it may imply that additional types of algorithms need to be utilized, not necessarily of which one provides the best result, but which one is the most explainable. The future of work, generally speaking, whenever you hear somebody talking about improving efficiency, that's code for getting rid of people. But that doesn't typically happen. Generally speaking, automation and the utilization of intelligence eliminates tasks, but not necessarily jobs. Business process automation is kind of an example of that as well. The basic idea is you combine together documents and workflows, and then you make sometimes autonomous decisions or automated decisions. It could be as simple as if a proposal comes through or a request for a discount comes through for a sale, and there's certain criteria that can be met. So it's under a certain dollar amount, the margins are a certain amount after the discount, and so on. Then you go ahead and approve the discount programmatically, automatically. So those sort of things can definitely increase performance and efficiency. May or may not, and typically don't, eliminate jobs. However, artificial intelligence definitely increases the pace of change. Things change more rapidly whenever you have automation and intelligence being factored in as part of the process. So the question is around robot rights is, should a robot have rights the same as a person? So as a thought experiment, if a robot approaches sentience, so it becomes self-aware, it becomes intelligent, um, is it being programmed and told to do something slavery because it's acting without compensation? If it can fear pain and death, is it alive? So if it tries to avoid its own termination and somehow can express that, is it alive? And should it have rights? Is kind of the follow on. So the question becomes, as intelligence increases, is there a point where uh, processes should be treated with the same degree of respect as people do? It's an interesting thought. I don't think we have to worry about it for quite some time because I don't think we're quite there. But if something were to reach sentience, it definitely becomes a relevant discussion. AI safety, kind of an important topic because we don't really want a robo apocalypse, right? We don't want the Terminator or the Matrix to become true. We have long ago broken the first law of Asimov's three laws of robotics, and a drone did it a long time ago. There's potentially also the unintended side effects of the implementation and the utilization of artificial intelligence. That's a real problem, one to be concerned with and focused on. Um, so we want to be cautious of maximization of utility being the only thing we focus on, because you may have a value alignment problem where uh, we humans become the hindrance to an algorithm reaching its maximization. So if you've got a robot whose job it is to mop the floor, and you have people that keep coming across and dirtying that floor, and the only thing the robot is concerned with is keeping the floor clean, eliminating the people might be a way to achieve that goal. So we want to make sure that there's not a misalignment of goals, so and that value. And so those are interesting things to consider, something to think about as you move forward. And with that, we reach the end of this discussion and also of these lectures. Thank you for listening. Thank you for joining this course and your work through this course. I wish you well. I hope you stay safe, and good luck with your future endeavors.